All right. So I'm here today to give you a rather small and high-level talk about using machine learning in industry, and that's based on my experience from working in the industry for the last 7-8 years, and from some projects we run with the engineering team that we have at the Castor C center of the Cyprus Institute. That there we run projects with either industry or academia that it tend to help companies or academic institutions or governmental organizations to adopt AI technologies. So my name is Christos Christodoulou. I am partly working at the Cyprus Institute at the moment. I am helping with leading the research engineering team and for designing the machine learning projects with mostly industry. So before I start, I want you to someone from you to raise your hand if you know where this image may come from. Yeah, good choice. It's not Midjourney. It's DALL-E 3. So the one by OpenAI. And disclaimer: most of the images that you will see are generated using that tool. Okay, an outline. So we briefly talk about benefits of machine learning, some popular use cases in the industry, some industry projects within the EuroCC project, and then some bit on the evolution of machine learning adoption in the industry. So probably you've read about this a lot. So there are at the moment an explosion in companies using machine learning for the reasons you see on the screen, and for many more reasons. Most of the companies use it for a lot for cost optimization. So they automate processes using machine learning, and that reduces costs. A lot of them use it for helping them with decision making, prevention of human error by having a human in the loop, but using a lot of AI to automate things. They use it a lot to create new products and services that have, machine learning in it. They streamline operations. We see a lot of AI being used in customer assistance, where agents, for example, operating a call center, can get assistance about questions from a user in real time and be able to assist the user. And other use cases, augmentation of creativity for creatives by creating images like they want to show you before to use in a presentation, and of course reduction of many repetitive tasks, leading to increased productivity. All right. So I picked up some of the use cases that I also have some experience with. I've worked with. So at the moment, I'm working at a healthcare company where we are using AI to create some sort of assistance, some sort of chatbots, and the reason there is to help in our case agents to retrieve information faster to be able to serve someone that's calling them. Another example I'm providing here. So we see an increasing use of tools like voice assistants, chatbots, or other conversational agents that are powered by machine learning. An example is HealthTap, which it's a chatbot that needs to improve user access to medical information. So you can just go to the app, ask questions. The questions that the application will give you, they are grounded on medical information. They try not to say things that are irrelevant. You can have a symptom and you can go online and check it. And at the same time, it can directly connect you to a healthcare professional. So the way that works is not to replace, let's say, doctor, but act as a front line before a request goes to an actual doctor. So a way this helps is by accessibility, convenience, so immediate medical answers, benefiting people that are very busy, efficient symptom checking, so quick symptom assessments, guiding users on whether to go see a doctor. It facilitates the virtual consultations, enhancing patient care. So it drives into a more kind of personalized and at any time patient care, and of course customer engagement and cost effectiveness. So another maybe not very well discussed way of using machine learning in big companies, also small companies, it's for controlling and monitoring the uptime and the reliability of their services. So you can imagine that big companies like the big ones, Netflix, Uber, Facebook, Salesforce, and so on, they are increasingly using AI to monitor their services are up and running. And they do it for the reasons you see at the bottom. So they enhance the uptime of their web services, so customers can see the service running more time. So they are using proactivity in detecting issues of something that might go wrong with an attack or system failure and so on. So they can, systems like that, they can detect and mitigate security breaches. And of course, it's cost efficient to automate all this and can provide many data-driven insights. So this is very hard to achieve this level of monitoring of reliability, because you can imagine a company like these big ones there, they would create millions probably of logs in their systems, and to be able to understand that information from in there, and in addition in real time, it would require a sophisticated form of automation. Okay, process automation. So companies like, for example, Orpheum, they use machine learning to automate time-consuming processes that are also prone to human error. So what Orpheum does is they are a copyright protection company for music. So what they do is they would go to YouTube, check all the videos that exist in YouTube, and check where they can find copyrighted content in there. So YouTube has an algorithm already there. So if you go there now and upload a video in YouTube with some music in it, it will pass through a copyright protection algorithm. But sometimes that algorithm would not, catch some of the cases. So these cases that were not catched, they would go to the Orpheum's algorithm, and they would try to catch them in order to. The idea there is when you catch a video using copyrighted material, all the advertisements that would be generated because of that video, they would create money, for the user. But if you are using copyrighted material, you are not allowed to get that money from YouTube, but the owner of that music would get the money. So instead of having an enormous fleet of users, humans, to go on YouTube, check whether there is music in the videos and what kind of music it's in there. So they have to go there and watch videos and listen to music. They would use this system to scan millions of videos in YouTube, detect whether there is music or not in there. If there is music or not if there is music in there, they would detect what kind of music is in there, what kind of song, and then they would go on and check how long is that music in that video, and then maybe pass it through a human person, and at the end be able to kind of flow the monetization in the correct channel. Do you have any questions up to this point? Feel free to ask questions. Okay, another example, it comes to fraud detection. Again, in a similar logic. So companies like Klarna, they are receiving users from a variety of sources, web application, mobile application, and so on. These users would go to that application in order to order something. And there are a lot of times that there are either bots or humans that are trying to, bypass the system to place, a transaction that is fraudulent and so on. So companies like this use machine learning to detect, irregular transaction patterns, anomalies in the way transactions are made, and they are, using all this data to create and adjust their models, train their models to be able to more efficiently, adapt and catch these activities. Of course. Yes.
How is this company getting paid?
They're working with big labels, record labels, or publishers of music, and they have an agreement with them. So if you sign a contract with us, and if we catch this, we get some part of the money. It's a Greek. It's a Greek American company. It's based in Athens, but has offices in Malibu. I worked there before, yeah. All right, and now some industry projects under EuroCC. According to Mandelis, I have to run now. I have to go faster. Okay. All right, one of the big projects we have in the context of EuroCC was about predicting the quality of polymer material in a production pipeline. So the idea here was that there was a company developing software that was used in production pipelines like oil and gas companies. And these companies have all sorts of sensors in the pipeline that measure different kind of quantities like temperature, pressure, and so on. And based on these quantities, every regular intervals, not so short, they would try to get the material, the quality of the material. So if the quality of the material was good, it would flow in batches through the system. It would end up with the rest of the material. If the quality of the material was not good, it should end up in another, basket that it would be refined or reprocessed. So the way that we were doing it before was very costly. They would lose a lot of material because of that. And the reason is that, if you don't detect that there is low quality material on time, it will contaminate the rest of the material. So they needed a way to be faster in detecting whether a material is of low quality, to be able to divert it very quickly. And this was, we had a multi-dimensional sensor data from a lot of points in the pipeline, all kind of in time series data. And the idea was to, at the end, do something like this. We had an actual, in the blue line was the actual, quality prediction of the material. And the red one was the one that was predicted by the model. So at the end, the person that did that was at the EuroCC before. So he used a couple of different models, did an evaluation at the end, and at the end, selected a model that would work with, high enough accuracy for this use case. We know that, this was created as a POC for the company. At the moment, we know that they deployed it in the actual production pipeline. So it works. Another use case comes with item recommendation. So who watches Netflix? Oh, okay. So about item recommendation. So we didn't do what Netflix did, but we wanted to do something similar. The company was had a lot of supermarkets as their customers, and the company would keep all the transactions that the customers would do at those supermarkets. So whatever they buy and so on, and plus the inventory of that supermarket. So what kind of materials the supermarkets would have at any given point. So the objective of the POC was to provide a recommendation system that would be based on estimating the association rules between different group of products to create that algorithm that would be better in recommending products to the users. And at the end, we created an algorithm that was better than the algorithm that they had before. And based on that, they took it some steps further to be able to use it in their pipeline. Okay, here's the similarity matrix. All right, some projects that we're working on now, we are at the moment doing some projects that use. Have a question? Okay, that use. You have a question? Okay. That use large language models, so generative AI to extract information. So some people in the team that are working on that. Why is this useful? Because information categorization it's very important in healthcare. So at the moment, healthcare is considered one of the industries that has fallen behind in terms of AI adoption. They have a lot of unstructured data, notes from doctors, lab visits, whatever. They're sitting in a lot of different systems. In Cyprus, some of them are also handwritten. And it's kind of very hard to categorize this data, to group them in specific fields, to normalize them, like, for example, using different names for the same thing, and to extract relationships out of them. It looks like something like this. So in healthcare, they have specific formats for describing healthcare data. On the left, you can see, so there are a lot of electronic healthcare records keeping a lot of information in a structured and unstructured way. So the goal of the project would be to take all the unstructured data elements and try to pass them through a big model, a large language model, and try to structure them following a specific schema that comes from this healthcare data standard. That's something that's in progress. It's very interesting because it has use cases, in all of hospitals, all of clinics. So something that's very important. Another one, again, working on information extraction in real estate. We're working with a company. They have a lot of PDFs having multiple pages of text. You can see it on the left. These 3 pages, we have up to 8 pages, I think, writing text about a given, real estate property. And we want to come from the PDF to something like on the right, having extracted information structured in a way that it can be used by a machine learning model. It can be used to create analytics about the market and so on. So last things. We can see recently that so the axis on the bottom starts from 2002. It goes up to 2022, and we can see that at some point, I think it was around 2015, 2016, industry started developing many more machine learning models than academia. So we can see by 2022, it's 6-7 times larger in terms of new machine learning models. Of course, industry has the advantage of having access to capital, more compute, and also they have large amounts of data that they can use. So it seems that they're taking the step ahead when it comes to usage of machine learning. And also, it seems that while 10 years ago, academia attracted most of the PhD graduates, now industry is the one that attracts them. So in red, it's industry, and in blue or gray, it's government plus academia. So we see that at the moment, industry has adapted to be able to accept this kind of graduates, to actually use them for their company. That's it. That's also Dali. Thank you very much. Thank you for watching. Do you have any